Welcome viewer, and this is Artistry. My name is Ndungu from SOS Technical Training Institute, and we'll be taking on electrical installation, and we are going to see the basics of this electrical installation. Now, electrical installation is the art of laying cables and the support structure to supply utilities. And utilities can be something from a lamp to an electrical machine. So that art of laying cables and all the support to supply an utility is what we refer to as electrical installation. Let us start with the history of this installation. Now, electrical energy started emerging in the late 19th century, and by that time other sources of energy were primarily coal and fuel. By the time this energy emerged, the most important thing for electrical energy was to do lighting. Was to provide light, and by that time, in the late 19th century, there were no qualified technicians or there are no qualified personnel to carry out this installation. So what used to happen is that because there are no people who are qualified to carry on this installation, installations were just done anyhow. But because they were not skilled, it resorted to so many electrical fires. It resorted to so many electrical fires. And when this happened, the insurance companies got concerned about the emergency of these electric fires, because after every now and then there will be an installation that is damaged by electrical energy, and the insurance company had to pay. So insurance companies pushed for some regulations so that to reduce the fires that were emerging every now and then. And when the regulations came about, the fires reduced. And so insurance companies were the architect of what are known as regulations. Today they are known as IEE. Today they are known as IE regulations, and this is what governs the installations. So all the installations that have to be done must conform to the IE regulations. And the reason why these regulations were drafted were because of safety. But now, other than safety, we also need standards. So number one was safety, number two, standards, such that we have uniformity, so such that when you move from one location to the other location, you get, if it is a lamp, you get the same lamp. If it's a socket, you get the same socket, and that is how it came about. But the main reason why regulations were drafted were because of electric fires, and the first people to call for these regulations were the insurance companies. And since then, the regulations have always remained, and electrical energy has remained to be a bit safer, and also standards have improved such that we have a uniform way of doing installation. And this one has made the electrical installation to be a bit safer and good. So we are saying that when electrical energy was came about or emerged, the main reason for use of electrical energy was seen in the lighting, was seen as for the purpose of lighting, because by that time there were no electrical lamps, so lighting was a problem. But when electrical energy emerged and we started having lamps, lighting became a reality and life became good. And even now, when you ask most of electrical customers, the most important need to do electrical, to have electricity, they will tell you for sure it is lighting, because that one has not changed. I think that one has not changed, it remains. But we have seen that as technologies have advanced and technologies have come, we have seen that now electrical energy plays a more important role other than just providing light, because due to electrical energy, that's why we are enjoying even the TV that you are watching now, the smartphone that you can't do without, and many other electrical and electronics gadget. So that's what has really happened. But for us here, we want to see how electrical installation is done. So this was part of the introduction about how electrical energy came about, and the most important aspect here is the regulations, because these regulations continue to play a very important role in guaranteeing safety and also the standards that we use. So we are going to see how should electrical installation should be done. How should it be done? Well, we are going to see some of the regulations that are very basic, and we need to understand them. One, when we have when we get power from the authority that supplies us with power, when we get electrical energy, the first thing is the connection to the grid, and we get something that is known as a cutout. Then from the cutout, we have an energy meter. From the energy meter, we have the main switch. From the main switch, we go to this one is normally referred to as CCU. This is the sequence of how power is applied to us. We are saying that from the mains we get a cutout, and what happens in this cutout is that we have a fuse and a neutral link. Then we need to measure the energy that we consume. Then we have a means of isolation, and from here, this is where we supply the utilities and other equipment. Now this will be provided by the authority supplying you with power, and in Kenya it is known as Kenya Power. But the rest falls under consumer, and we have the sequence as that. Now when we come to regulations, the first regulation is that when you want to supply any load in a domestic installation, then all the load must form a circuit at the CCU, and the regulation states that all final circuits all final circuits sub-circuits must be the first regulation that we encounter is that all final sub-circuit must be protected by a fuse or an. Now, the statement is noted here because if we say that all the final circuits must be protected by a fuse or an MCB, then there is an omission because we don't know how big is the circuit breaker. We don't know how big is the circuit breaker or the fuse. But when it comes to final circuits, there is a regulations on fuses and MCBs. And the regulation states that the lowest rated conductor in a circuit must be able to carry the fusing current. The lowest rated conductor in a final sub-circuit must be able to carry the fusing current, meaning that if the fusing current is 10 amperes, then all the conductors forming that final sub-circuit must be able to comfortably carry that current without any issue. And that's how you will see that some fuses or MCB are rated. We have rating, and this rating is in amperes, and the rating is always in considerate of the lowest rated conductor. In our previous presentation, we have indicated that current will flow, but the maximum amount of current that can flow in a circuit is always determined by the cable size. So if you have a large cable, then it means that it can be able to allow higher current to flow. If you have a small cable, then it means that only a small amount of current can flow. So that's why we have this cable size, we have rating, and we have the fuse or MCB that would be protecting the circuit. Now, the reason why we need a fuse or an MCB is not to protect your equipment. It is not to protect the customer's equipment or anyone's equipment. The purpose of the fuse or MCB in installation is to protect the installation. So what is being protected here is not the equipment, but the installation. So it is the installation that we are trying to protect. And when we are talking about the installation, we are talking about the conductors, the switch gears, and any other arrangement forming the installation. That's what we mean by the installation. So the purpose of the fuse or MCB is not to protect the equipment, but it is to protect the installation itself. And how do you protect the installation itself? Now, we know that in an installation, because of one reason or another, there could be a fault. There could be a fault, and this fault could either be because of a broken insulation, or an overload. Number two, So a fault could either be because of a broken insulation, and a broken insulation most of the times gives a short circuit. It gives a short circuit. It gives a short circuit, but an overload does not necessarily give a short circuit. But what it happens is that the circuit draws more current than the one that is rated, and because of that, you find that the conductors will start heating. The conductors will start heating, and because of that heating, we might lose our installation, because if we have the installation heating, then there are high chances that we are going to suffer more broken insulation that would mean more short circuit. So because of that, that's the reason why we need to protect our installation. So we have it like so. So when it comes to electrical installation, these are the very basics things that either a technician or a customer should understand. Number one is that we work depending, or we work guided by the regulations. We have what we refer to as IE regulations, and the reason why we have this regulation is, of course, to guarantee safety and standards. So, and when we observe them, we reduce the risk of fire, and we make the installation more safer. We have also looked at the sequence of equipment that we get, so that we get power from Kenya Power. We have seen that we have a cutout, we have an energy meter, we have a switch, main switch, and the consumer control unit. On consumer control unit, we have seen that according to the IE regulations, all final sub-circuit must start from somewhere, and they start from the CCU, and they must be protected by a fuse or an MCB, plus the reason why they have to be protected by a fuse or an MCB is because we want to protect the installation. We have also seen about the rated the rating, and we have said that for any final circuit protected by a fuse or a circuit breaker, the lowest rated conductor must be able to carry the maximum fusing current, and that's what we should always bear in mind. And with that, we come to the end of our presentation today. My name is Ndungu. I was taking you through, and keep watching.